3.1, investigating properties of triangles. We've done a little bit of an investigation dealing with the balance point of a triangle, and we learned that the medians, all three medians of any type of triangle, will go through the balance point. Good. That means we need a name for that point that's more mathy than balance point. But before we do that, you have a note on the word concurrent. Concurrent. Nope. Concurrent. You have a little triangle here. Help us talk about some things. Okay. Concurrent simply means meeting at a single point. Meeting at a single point. Uh-oh. Something about lines that meet at points. You familiar with that concept? Yeah? Point of intersection, solving linear systems, unit 1, 2, 3, all coming together. Okay? Concurrent is meeting at a single point. And centroid. Centroid is the point where the three medians of a triangle, the point where the three medians of a triangle intersect. All right, you're going to be dealing with some intersection of lines. So let's think about these medians. You already did an investigation, so I'm just going to do a bit of a drawing here and hope it works out. I'm not even going to measure. I'm just going to kind of estimate. I need the midpoint of this side. Okay? Notice I need markings to show that I found the midpoint of this side. Now, if I draw a straight line, that should go through my balancing point. It should go through my centroid. How do I find that centroid? Well, I actually need at least two medians to be able to find that centroid. So I'm going to draw the midpoint of another side, okay? As I'm doing this in my work, using algebra, using my midpoint formula, I'd be labeling all these things, keeping my work nice and organized. Let's call that one D. Let's call this one E. And if I'm drawing a diagram, which I'm going to have to do a lot this unit, I also want to note that this is the midpoint, which means it's bisecting this line, this side of my triangle. Now, notice I used a double hash here and a single hash here. That's because I have not said anything about the relationship between this length and this length. Okay, they're not necessarily the same, so I need to use a different symbol. If I used a double hash on all of them, I'd be saying this is the same as this, is the same as this, is the same as this, and that's not true. Or it doesn't need to be true anyway. And I'm going to go ahead and draw my median from this vertex. And what I find out when I do that is that this point right here, this point of intersection of my medians, is the centroid. Okay, so let's go ahead and label some things here. This line is a median. Okay, this line is also a median. May as well do that up. And this point right here is a centroid. Now, do I need the third median in order to confirm that this is the centroid? I don't. If I've done my math right, 2 is enough. Okay? If you're asked to get all three medians and then you're asked to find the centroid, you can just use 2 of the equations, 2 median line equations, and then find that middle point. But we could also draw that third median, and if we did, it would go whoop, right through the centroid. Okay, that means these two medians, my red median and my blue median, are concurrent. They meet at the same point. Okay, or at least they're concurrent at this point, and that point is the centroid. There's just one example for this lesson, and it deals specifically with isosceles triangles. Median of isosceles triangles. And again, it's just all about properties. So what does it say? What are the properties of the median from the vertex between the equal sides of an isosceles triangle? So do you have a picture of an isosceles triangle in your book?
No.
Go ahead and try and draw one as accurately as you can. I did a nice wide one. And if it's not good enough, then I might just change it a little bit.
I mean, it doesn't really matter what you draw, it's just what the marks say.
That is true. Okay, that's a good lesson for this unit as well. Your drawings aren't going to be perfect, but how you mark it tells the truth about that shape, whether it looks like it or not. Okay, so I'm going to go ahead and draw what I know to be a median. Okay, I've measured this out, my median, my midpoint of, let's label our sides, let's call this A, B, C.
Sides or vertices?
Yeah, angles, one mistake, sure. Okay, there's my median in blue. My median from A goes through the midpoint of BC. I want to show that it's going through the midpoint by showing that I've actually bisected that base, that line. And go ahead, tell me something that you know is true.
They have 2 equal sides.
Okay, so it bisects the opposite side. Yeah, that's the definition of a median. So you wouldn't necessarily include that in the properties because that's literally what a median is. So what else could you say? What else do you notice that happened here?
The 2 sides of the triangle on the different sides of the median are equal.
Yeah, these guys have equal area. It split it in half. Every median does that, just so you know. Every median of a triangle, that's the investigation that we did. Anything else? Let's talk about it as much as we can, and then I'm going to jot some things down for you. What else does it look like it might have done?
Form 2 right angles.
Yeah, look at this. The median of the isosceles triangle met BC at a right angle. That did not happen in your earlier investigation unless you did a right angle triangle. Okay, so that's new. I also want to make sure I noted that this is a isosceles triangle. It's got equal side lengths there. All right, I'm going to jot some things down here. And try to explain them as I go along. The median includes all points equidistant from B and C. Copy that down and then we'll talk about it. The median includes all points equidistant from B and C. So this is going to be the answer to one of your communications questions from last unit. But if I'm looking at this median that I drew, this point is called the midpoint. It's obviously equidistant from B and C. But look at this point down here. It's on the median, and it's also equidistant from B and C. You don't need to draw that line necessarily. I could take another point. I could take a point up here. It's also equidistant from B and C. So this blue line contains an infinite number of points, and every single one of those points is equidistant from B and C, and every point that is equidistant from B and C is on that line. So if I took a ruler and I went from C and I measured, let's say I had my compass, my spinny thing, and I drew an arc, a 10 centimeter arc like that, and then I went from B and I drew a 10 centimeter arc like that, where they cross will be on this line. Okay? It's equidistant from both sides, so it's on that median. That's a property of the medians of an isosceles triangle. That is not true in any other kind of triangle. Okay? What else can we say about this? The median from vertex A is perpendicular. We got that one. The median from A is perpendicular to BC. We drew that one with a little right angle symbol here. By the way, this top one, the median, this has to say also from A. It's only true of the coming from the vertex that is not an equal angle. Okay, it's coming from the other side, I guess you can call it. Good. What does that mean? So if this guy goes straight through the bottom line and it's perpendicular, this median is also what? It's also the altitude, okay? The median from A is also the altitude
Of ABC.
of ABC, triangle ABC. What does altitude mean?
How high it is.
The height, okay, the height. Why is that not true in other triangles? Well, in other triangles, the altitude,
It's where the
which is the line that marks the height, always meets at a right angle, but is that the median?
no.
No, because the median would go through the midpoint, right? Okay, not the same line. But in an isosceles triangle, it is the same line. What else can we say? Triangle ABC, ABC, and ACD. This point is called D, and I'll erase these guys for us for a second. They have a side in common. They have the side AD in common, and they have other corresponding sides as well. So this bigger triangle is actually congruent. Sorry, I should say that these two smaller triangles are congruent, okay? Because this median splits it exactly in half and forms a right angle triangle, these guys are congruent sides. DC is congruent to BD. Congruent means they're the same length, okay? And AD is in both triangles. So it's congruent in each triangle. And we already know because of an isosceles triangle that these two outside lines, AC is congruent to AB. Therefore, our two little triangles that are formed are congruent. Triangle ADB is congruent to, let's not do that. Let's write it, is, or let's say and. Triangle ADB and triangle ADC are congruent. Good. What else does that tell us? Something about if they're congruent, if these triangles are congruent, it's obvious that these two angles are the same. Angle D is the same in both triangles. Angle B is also equal to angle C by definition of an isosceles triangle. What does that tell us about these two angles?
They're the same.
Okay, so if those two angles are the same, what does that tell us about this line and the original triangle?
That line makes two more equilateral triangles.
It bisects. The median bisects angle A. The median from A bisects angle A. Okay, that is not true in any other type of triangle. Here's a median in this triangle. Okay, these two angles are clearly not equal. X and Y are clearly not equal. Y is smaller than X, even though I drew a median. Okay, it's only true in an isosceles triangle. So the median from the vertex between the equal sides of an isosceles triangle coincides with the altitude and it bisects the angle.
What about an equilateral triangle?
Okay? Is an equilateral triangle an isosceles triangle?
No, but you said it was.
Nope, don't answer so quickly. Is an equilateral triangle an isosceles triangle? What's the rule for an isosceles triangle? Two equal sides. Does an equilateral triangle have two equal sides? Yeah, it does. Has three equal sides. So an equilateral triangle is an isosceles triangle. Not every isosceles is equilateral, but every equilateral is isosceles. So these things are all true of an equilateral as well. Yeah? Okay. We have 1, 2, 3, 4, 5 properties of an isosceles triangle for you. Those are things that you should be able to now know and use and draw and help in your problem solving.
Okay.
Your practice problems for 3.1 are in the booklet that you have. It's in your student booklet. It's worksheet 3.1. You are responsible for working through 1 through 4, 5b, 6, 8, and 9, and 14c. Some of them are not super easy. It's a lot more thinking and writing and explaining, drawing diagrams, okay, that kind of stuff. So work through it carefully and try to memorize the things that you're learning, the properties that you're learning.